Hi, welcome to all. I am Pradhosh Kumar, working as an assistant professor in the Department of Biomedical Engineering, Sri Shimoga College of Engineering Technology. In this session, I am going to discuss about filters. Introduction to filter. Introduction to active filters. Filters are circuits that are capable of passing signals within a band of frequencies while rejecting or blocking signals of frequency outside this band. This property of filters is also called frequency selectivity. There are two broad categories of filters: analog filters, which process continuous time signals, and a digital filter, which processes discrete time signals. The analog or digital filters can be subdivided into four categories: low pass filters, high pass filters, band stop filter, band pass filters. This is a diagram of ideal filters. First is the low pass filters. The aim of this low pass filter is to pass or allow only the low frequency signals to pass through. Next is the high pass filters. So this filter is used for allowing high frequency signals to pass through the system. So here we are allowing only the high frequency signals, that is above the range of omega c, the frequency range. Next is the band stop filter. This filter is used for allowing the signals which is of low frequency and high frequency, but it will stop the frequency which is the middle frequency, that is the central level frequency. That's why we have used a stop band there. Next is the band pass filter. This filter will allow the frequency which is available at the center of the filter, that is the middle values of the frequencies will be allowed, and it will stop the lower frequencies and higher frequencies. These are the categories of filters. There are two categories of filters. First one is the passive filters and the second one is the active filters. First we will discuss about the passive filters. The circuits built using RC, RL or RLC circuits comes under the list of passive filters. The passive filters use resistors, capacitors and inductors to minimize distortion in the filter characteristics. It is desirable to use inductors with high quality factors. Practical inductor include a series resistance. They are particularly non-ideal, they are bulky and expensive. So this is considered as the drawback of this filter. Next is the active filters. Active filters, the circuits that employ one or more op-amps in the design, in addition to resistors and capacitors, are considered as active filters. Active filters overcome the drawbacks of passive filters and are realized using resistors, capacitors, and active devices, which all can be integrated to form an active filters. Active filters replaces inductors using op-amp based equivalent circuits, so that we are overcome the drawback faced by the passive filters. These are the advantages and disadvantages of active filters. The major advantages of active filters include reduced size and weight, increased reliability and improved performance, simpler design than passive filters, and can realize a wider range of functions as well as providing voltage gain. In large quantities, the cost of an IC is less than passive counterpart. Disadvantages of active passive filters: limited bandwidth of active devices limits the highest attainable frequency. Passive RLC filters can be used up to 500 MHz. Require power supplies, unlike passive filters. Increased sensitivity to variation in circuit parameters caused by environmental characteristics compared to passive filters. So these are the advantages and disadvantages of active RC filters. First we will discuss about the low pass filter. A low pass filter is a filter that passes frequencies from 0 Hz to critical frequency (FC) and significantly attenuates all other frequencies. That is, a low pass filter will allow only the low frequency signal to pass through the circuit, that is from 0 Hz to critical frequency (FC), and attenuates the remaining frequencies. So this is the actual response. So actual response will be like this, which is shown in this figure, where we will be allowing the low frequency signals to pass through. That's why we have shown the pass band there. And the higher frequencies we are seeing that roll off rate, so that it will reach the higher frequency will be filtered. It will not allow to pass through the circuit. So B is the basic low pass circuit. We are using the RC circuits, that is the supply is given and a resistor, and an output we are connected through a capacitor. So the third case is the ideal response of this. So ideal response, we can see that a constant value of low frequency will be allowed and the higher frequency will be fully cut off. So this is a lower frequency is considered pass band and higher frequencies a stop band we are showing the figure. So next, low pass filter, the bandwidth of an ideal low pass filter is equal to FC. That is the bandwidth range, the range of frequency which is allowed, we are considering that as the FC, that is a critical frequency. The critical frequency of a low pass RC filter occurs when Xc equal to R and can be calculated using the below formula. That is, critical frequency is given by 1 by 2 pi RC. From this we can able to find the critical frequency. So these are the things about the low pass filter. So next is the high pass filter. A high pass filter is a filter that significantly attenuates or rejects all frequencies below FC and passes all frequencies above FC. That is, below critical frequency will be attenuated and above the critical frequency only be allowed to pass through the circuit. That is about the high pass filter. The pass band of a high pass filter is all frequencies above the critical frequency, and the remaining will be the stop band. So this is the circuit of the high pass filter. First we have shown the that is a practical case. So we are seeing that only the frequency above FC is shown as pass band and the below frequency are considered to be stop band. Next is the figure B, which is showing the circuit of this. That is, input will be given and a capacitor and resistor will be used where the output will be taken across the resistor. So the third case is an ideal response where we can see the lower frequencies are cut off and above the cutoff frequencies are allowed. That is a constant values we are showing. That is an ideal response of this. So this is the formula for finding the critical frequency, that is 1 by 2 pi RC. So the critical frequency occurs when Xc equal to R, and this is the formula of it. So next is the band pass filter. A band pass filter passes all signals lying within a band between a lower frequency limit and upper frequency limit, and essentially rejects all the other frequencies that are outside the specified band. Only the frequencies that are within the particular band will be allowed to pass through by the band pass filter. So we are seeing the frequency that lies between FC1 to FC2 will be allowed to pass through the circuit, and the lower and the very high frequency will be rejected. So this is the actual response of the band pass filter, where we can see the FC1 to FC2 is the allowed range of frequencies, and the next figure is the ideal response. So the lower frequencies and very high frequencies are cut off, and the range of frequency in the middle will be allowed to pass through. The figure shows the graph between the x-axis frequency versus gain. So this is the equation to find out the bandwidth. That is, the bandwidth is given by FC to the higher cutoff frequency minus the lower cutoff frequency FC1. So it is defined as the difference between the upper critical frequency and the lower critical frequency. The frequency about which the pass band is centered is called the center frequency. The frequency which exactly lies between the lower cutoff frequency and higher cutoff frequency is called as the center frequency, and it is given by f0 equal to root of fc1 into fc2. This is the band stop filter. A band stop filter is a filter which its operation is opposite to that of a band pass filter. So previously we have seen the band pass filter where the center range of frequency will be allowed to pass through, but here we are rejecting the initial frequencies and the very high frequencies. So band stop filter is a filter which its operation is opposite to that of a band pass filter, because the frequencies within the bandwidth are rejected and the frequencies above FC1 and FC2 are passed. So this is a diagram which is showing the band pass filter. The first one is the practical case, and the second one is the ideal response of a band stop filter. So it is allowing the initial lower frequency and higher frequency, and the middle frequency will be stopped. Hence, it is shown as stop band filter. Stop band in the middle. Thank you for listening to this section.